Have you ever wondered what makes soda pop? It's a question that has intrigued many of us, especially when we hear that satisfying hiss as we open a can. Why does it fizz and bubble so energetically? The answer lies in a gas called carbon dioxide, or CO2 for short. It's this gas that gives soda its unique, bubbly sensation that tingles on your tongue. Carbon dioxide is actually all around us in the air we breathe. We exhale it with every breath, and plants use it during photosynthesis to grow. But in soda, this gas is trapped under high pressure, just waiting to be released. When you open a bottle or can of soda, you're letting go of that built-up pressure. The carbon dioxide escapes rapidly, forming tiny bubbles that rise to the top of your drink. That's the delightful fizz we all know and love, adding excitement to every sip. So next time you enjoy a refreshing soda, take a moment to appreciate the science behind those delightful bubbles. It's all thanks to the magic of carbon dioxide and a little bit of pressure, creating a fizzy experience that's simply irresistible. Carbon dioxide, or CO2, is a colorless and odorless gas. It's a natural part of our atmosphere, present in small amounts. Plants need CO2 for photosynthesis, the process they use to make their own food. We exhale CO2 with every breath we take. CO2 is also used to make drinks fizzy and enjoyable. When CO2 dissolves in water, it creates carbonic acid, which gives soda its tangy taste. This process, called carbonation, is what makes soda so refreshing and bubbly to drink. Carbonation is the process of dissolving carbon dioxide gas into water under high pressure. Imagine filling a balloon with air. You're forcing more air into a confined space. That's similar to what happens when soda is made. CO2 is forced into the liquid under high pressure. This pressure allows more CO2 to dissolve than would normally at room temperature. It's like squeezing more air into that balloon. The result is a liquid that's super saturated with CO2, ready to fizz when the pressure is released. Section 4. Pop goes the fizz, releasing the pressure. When you open a bottle or can of soda, you're releasing that built-up pressure. This pressure is what keeps the carbon dioxide dissolved in the liquid. It's kind of like poking a hole in a balloon. The air rushes out. The same principle applies to your soda. As the pressure drops, the CO2 molecules can no longer stay dissolved in the water. They start to form bubbles. They escape in the form of tiny bubbles. These bubbles are what give soda its characteristic fizz. These bubbles rise to the surface, creating the characteristic fizz of your favorite drinks. The more bubbles, the fizzier the drink. The more pressure released, the more dramatic the fizz. This is why shaking a soda can before opening it can cause an overflow. That satisfying pop when you open a can, it's the sound of the pressure being released. That's the sound of pressure being released, allowing the fizz to begin. Enjoy the refreshing sensation of those tiny bubbles. Section 5. Chill out, temperature's role in the fizz. Did you know that temperature affects how much fizz a drink has? Colder temperatures can hold more dissolved CO2. That's why a warm soda will go flat faster than a cold one. The warmer liquid can't hold on to the CO2 as well. Think of it like a crowded room. It's easier for people to leave when it's hot and uncomfortable. Similarly, CO2 escapes more easily from a warm drink. So, for maximum fizz, enjoy your soda ice cold. The colder temperature helps keep those bubbles trapped, ensuring a more refreshing experience. Section 6. From science to soda, our favorite fizzy drinks. The science of carbonation is what makes so many of our favorite drinks possible. From classic colas to sparkling water, the fizz adds a fun and refreshing element. Fruit-flavored sodas use CO2 to add that extra zing. Even some alcoholic beverages like beer and champagne rely on carbonation for their bubbly character. The next time you enjoy a fizzy drink, take a moment to appreciate the science behind it. It's the perfect blend of chemistry and physics that creates those delightful bubbles we all love. Section 7. The appeal of fizz, why we love bubbly beverages. Why do we find fizzy drinks so enjoyable? Is it just the taste, or is there something more to it? The answer lies in the unique sensation they provide. It's not just about flavor, it's about the experience. The bubbles bursting on our tongue create a tingling, refreshing feeling. This effervescence is what makes each sip so invigorating. This sensation triggers our trigeminal nerve, the same nerve responsible for our sense of touch and temperature in the mouth. It's a fascinating interplay of our senses. It's a different kind of taste experience, one that combines touch, taste, and even sound. The sound of the fizz, the feeling of the bubbles, and the refreshing taste all combine to create a multi-sensory experience. It's a symphony for your senses. So next time you reach for a fizzy drink, remember that you're not just quenching your thirst, you're engaging your senses in a unique and enjoyable way. It's a small moment of joy. Cheers to the science of fizz. Here's to the delightful bubbly beverages that bring us so much pleasure.